We're going to look at ray diagrams for converging lenses. We have two problems here that we're going to be taking a look at. So you can see we have our scale drawing of a convex lens, as well as all the classification types on the right-hand side. So a 1 centimeter tall object is placed 2 centimeters in front of a converging convex lens with a focal length of 2 centimeters. So we can go ahead and put in our focal length. And let's review what we were given in the problem. A 1 centimeter tall object, that is the object height, 1 centimeter tall, is placed 2 centimeters. That is the object distance, the distance from the lens line to the object. And we've already identified the focal length on the right. So we need to measure 2 centimeters out from our principal axis, and we need to construct our object, and we need to measure carefully so that it is exactly 1 centimeter tall. So we've measured exactly 2 centimeters from our principal axis, and we've constructed our object so that it is exactly 1 centimeter tall. Okay, so now we're ready to begin with our ray diagram rules. Rule number 1, a ray drawn parallel to the principal axis is refracted through the focal point. So we draw it parallel to the principal axis. Rule number 2 says a ray drawn through the focal point is refracted parallel. But if you look, our focal point, which is right here, we cannot go from the top of the object through the focal point and intersect the line that passes through vertically the center of the mirror. So we actually cannot do rule number 2. Let's take a look at rule number 3. A ray drawn through the vertex of a lens passes through unchanged. So we're going to connect the top of our object through the center. And you should notice something very interesting about those two lines. They're not going to intersect. Those lines are parallel. That means if those rays never intersect, we have no image. That means there's nothing more that we can do in this problem. There is no image. We have parallel lines here. The rays do not intersect. So we have no image. And that is always going to happen when the object distance is equal to the focal point for converging lenses, or mirrors actually. So let's move on to the next problem. We have a 1 centimeter tall object, 1 centimeter in front of a converging lens with a focal length of 2 centimeters. So I have a 1 centimeter tall object. That's HO is 1 centimeter. The object distance is 1 centimeter. And my focal length is 2 centimeters. So let's go ahead and measure carefully using our ruler and then draw our image. Our object, excuse me. So there we have our object. Rule number 1, a ray drawn parallel is refracted through the focal point. Rule number 2 we can't do, but we can do rule number 3, a ray drawn to the vertex passes through unchanged. So we have rule 1 and rule 3 drawn. You'll notice that these lines do not intersect, but are they parallel? No, they are not parallel. So it turns out they will intersect. They just will not intersect on the real side of the image. which is to the right of the lens. So they will not intersect anywhere over here on the real side. So where will they intersect? Well, we have to sort of figure that out by extending the refracted rays. So those are the rays on the right-hand side of the lens. So we're going to extend this line backward. And we'll do the same with the other line. So we've extended the green ray back, now we have to extend the red ray back. And you can see that they do intersect, but this time they intersect on the virtual side of the image. So we will connect that point of intersection with the principal axis, and you can see that that is our image location. So right away you can see this time that our object is upright and it's bigger, and it's not on the real side, so we know that it is virtual, bigger, and upright. And so we'll just verify that with the math. So the equations are if I do, I die. Our focal length in this case was 2. Our object distance was 1. So when we solve that, negative 2 centimeters, which means it should be 2 centimeters behind the lens, and in fact it is. We'll now verify the image height with the magnification equation. So magnification is equal to I-ho negative d-do. And so we'll plug it in. So our image height is what we're looking for, equals my image distance, which is negative 2, so that's going to be positive 2, over my object distance, which was 1. And you can see that HI is plus 2 centimeters, so it's 2 centimeters. And it's going to be twice as big, 2 times. So it's upright, it is virtual, and it is enlarged. And that is what it looks like when the object is closer than the focal length. And so you just need to know your rules for ray diagrams. A ray drawn parallel is refracted through the focal point. A ray drawn through the focal point is refracted parallel. And a ray drawn to the vertex of a lens passes through unchanged. Hope you understand and enjoyed learning about ray diagrams. Take care.